Today's webinar is Introduction to HPC Private and Public Cloud with COMSOL. A little bit about TotalCAE. TotalCAE is a simulation as a service company. We provide on-premise high-performance compute clusters or public cloud computing for our customers that is completely managed by TotalCAE. By managing these systems, we remove the barriers to adopting either high-performance computing or public cloud computing for your engineering workflow. We have over 20 years of experience focused solely on engineering IT solutions. The main thing that we do is help simplify complexity. High-performance computing has not been widely adopted by many customers because of its too complex for IT, and they do not feel that they're able to obtain HPC and make it a reliable tool for the engineering community. Public cloud is also complex and requires even more IT skills than on-premise high-performance computing, and creates yet another barrier to entry for companies that are wanting to adopt high-performance computing on the public cloud. A lot of times our customers have went to other vendors or tried to acquire or create a solution either on public cloud or in-house for high-performance computing, and they might have got something that sort of worked, and then the people who set that up then left. And then the customer, that works for a while, but then something goes wrong and the customer is not able to recover. They have a deadline. They can't understand why is their model not solving. Perhaps it's a problem with the cluster. Maybe it's some issue with the model. Maybe there's some bug in the solver. They do not know who to talk to, and they end up having to try to go to a whole bunch of different people to kind of put together the mystery. And what TotalCAE does is solve that problem. If you're exasperated that you can't figure out why you can't get your engineering work done, with TotalCAE, you have one throat to choke. We are the sole provider of all of your engineering HPC for either that be the high performance computing cluster, the application, the license server, the public cloud. You come to TotalCAE and we solve and manage all those solutions. We either will manage your high performance computing data center, or we will manage your public cloud, the TotalCAE public cloud. So you have just one vendor you have to go to for all of your simulation needs, and we will take care of trying to track down any issues that might occur, and we proactively work around the clock to prevent any kind of problem that you might have. And we hide a lot of the complexity of both high performance computing and public cloud behind a simple to use web portal. This web portal makes it easy to basically set up a job to run on high performance computing for over 50 some applications. Just a couple clicks and you can be off and solving. So today we're going to be looking at COMSOL. So this is the web interface that we have for COMSOL, which we'll demo in a minute. You just basically select the version of COMSOL, your input deck, how many cores you want, and off you go. So we're going to do this demo right now so you can see how easy it is. So I will bring up a web browser. This web browser is actually, I'm already logged in, and it's pointed at a public cloud instance. This cluster is dedicated to a specific customer. It's only accessible to them. And I've already selected the version of COMSOL in my input deck here. I have uploaded that from the PC. Also selected the number of cores, and I simply push the button. What I can now do is then go over and see my job, and I can see that this job is running. And I can get some details about the job, like where it's running, maybe some comments I might have put on. I can go browse and look at the files, which we'll do in a minute. I will get an email when the job completes, and then I'll know to come back here to download the results. We also can see the public cloud, how many cores we have. Right now I've turned all these on, but the system will automatically, on a public cloud, turn on and off the nodes as they're needed so that you only pay for what you use. Currently, I just submitted this two job here, so this is what they're using. Let's go back and just check. My job is completed. So I will want to download the results, so I can just go over here and we can just double check out what happened with the model. I will open up the item, and here we can see that we successfully solved this tuning fork model. You can download the results and then do post-processing here on this workstation, or I could also do it on the public cloud. So that is how easy it is to use the TotalCAE portal. We also give you the ability to monitor your licenses. So in the case you wanted to see like how many licenses you have, you could see how many are available or use. You can also get information on all of if someone's using the license and you're wondering who it is, or you can call them, you can get that kind of information. Now, the public cloud is generally unlimited amount of compute resources. However, many customers may be limited by your licensing, and that is kind of application specific. So the TotalCAE portal will calculate the number of licenses you need and make sure your jobs will queue if for some reason those licenses are tied up by maybe some on-premise application or some other user or other jobs. So when deciding, should I go into the public cloud or should I have you manage maybe some hardware that we're going to have in our data center? Really, these are the two choices. And what we call private cloud or the on-premise system has an advantage that you have an unlimited simulation for a fixed monthly cost. So you can, within the bounds of the hardware you have, if you're most customers are not bound by hardware, you can throw as much workload as you can at it, and you always will have this paying the same monthly cost. Most of the on-premise systems, you don't purchase them necessarily. You can lease them. You could buy them outright. But for a fixed monthly fee, kind of like leasing a car, you get access to all the simulation you can do on that in those bounds. It has the very fastest data transfer because it's right on premise, next usually very close to where your engineering workstation is. And it's definitely a cheap solution, the cheapest solution if you run simulations every single day. So if you're doing simulation multiple times a day, all day long, 5 days a week, multiple engineers, definitely owning that asset it's really fairly cost effective. The cost of simulation really is, the engineer followed by, the software tools or sometimes the software tools and the engineer, and then kind of the hardware is always a dead last. Hardware is fairly a small part of the overall engineering cost. It's also the simplest workflow. It's just how you work today. There's not a whole lot to change. And accessing high performance computing on premise is actually easy with a provider like TotalCAE because we'll manage the HPC for you. So you don't have to worry about being a high performance compute expert. Your IT does not have to worry about Linux or high performance computing or your applications. All of that, all of your apps, your licensed servers, the HPC, everything will be managed by TotalCAE. A disadvantage, however, of private cloud is there is a longer procurement cycle. Anytime you want to purchase anything, there is usually some, you have to go through the purchasing process, which may take longer than if you're on a short deadline, than you need. There needs to be a data center with power and cooling. These types of very high performance compute systems don't sit under your desk, and usually the lease or buy does require you to get some sort of upper level approval. The type of hardware for COMSOL is very memory intensive, so we recommend having 8-core processors. You want to keep the memory channel to core ratio down. Now, if you have more than 8-core processors, we can configure COMSOL to just use less of those cores to get better memory bandwidth. On a modern system as of this webinar, you can get 128 to 500 gigs of DDR4 memory. So you've definitely, if you're going to spend your money, you want to spend it on memory more than fast processors. If you're doing a lot of inter-node communication, you may want to consider an FDR InfiniBand on your cluster. And a lot of these rules of thumb are solver and model dependent. So depending on the physics that you have or what you're doing, can make a big difference on, kind of how much memory you may need or what types of activities you will want. So, we will help you benchmark your best configuration. We'll work with your COMSOL rep and then get you a benchmark of your representative model so you can kind of know exactly what kind of speed ups you can expect on your day-to-day models. It's also possible using COMSOL multi-physics server, COMSOL server, you could just get a super workstation that has a lot of memory, helps with when you have lots of physics, and just point your COMSOL multi-physics client at the server and do the calculation on a sort of a super workstation, which we'll show a little bit later in this webinar, solving on a 1 terabyte cloud super server using COMSOL multi-physics. So public cloud. So the public cloud is also a very complex system that lets you basically rent. And the nice thing about the public cloud is that you can just turn it on and off. So if you're not using simulation all the time, or maybe you just need access to a large amount of memory, let's say for maybe a few weeks, or a month, you can just turn that capacity on, pay for that compute time, and then turn it off, and then you don't need to pay for it if you're not using it. And so this is just basically a form of renting. So when you are using these computers that are not in your data center, you're renting them from another provider. In this case, it'll be TotalCAE, who's acquiring from the major cloud providers, including AWS and Microsoft Azure. Now note that renting isn't always cheaper than buying. So a lot of these public cloud systems are quoted are what are called a per core hour. So you pay 6 cents for every core, and a core is like a CPU. And so if you have 5 nodes, it's 6 cents per core hour. That sounds pretty cheap. If you use it all the time. Let's say you just left them on and you're doing simulation, around the clock. That ends up being $315,000 over 3 years, and you could have easily bought that capacity for $40,000, $50,000, and over a 3 year period, you would have saved over a factor of six to acquire that same exact amount of computational power. So utilization is a major factor in whether you should buy or rent. So in this case, if you have a simulation that you're 90% of the time you're running simulation on premise, you would buy for that 90%. You wouldn't buy for the peak that you might see here at the 100%. You could always rent that, you choose, or just wait or queue. But in this case, it would be much cheaper to own the on-premise capacity than to rent it 100% of the time when you're having this constant baseline. However, this is the exact opposite. You may be able to just rent all the time. If your utilization is low, it may not be worthwhile, especially if you have just very seasonal or peak type of simulation needs. Maybe you have a singular event that you're preparing for. You have to do a lot of maybe upfront simulation, and then you don't do a whole lot throughout the year. This may be the case where you would definitely be in a better position to rent compute capacity than perhaps try to own it. One interesting item that we have seen as cloud computing has gotten more interest is that simulation as an expense often ends up having people who classically weren't interested in how simulations were done suddenly becoming very interested in how to control the expense. So if you have used to having an on-premise system, they're often wanting to know, why can't the engineer work on the weekend and in the middle of the night, because they want to have very high utilization of their assets. However, once it becomes an expense, they're always wondering, well, how can we stop you doing so much simulation? It's costing quite a bit of money. Every simulation costs money, and then you start to ask, do you need to do all this simulation? Or could you just reduce the amount of simulation you do? And it's a kind of interesting paradigm shift that when simulation becomes an expense that someone comes out of someone's budget, you definitely will see kind of a shift in the discussion of how simulation is done. The other thing that's kind of interesting about simulation as expense is that now when you make a mistake in the model, it actually costs you money. So if you have a typo and you are renting the compute time and you discover it like sometime into the middle of the model is not converging or something, you're like, oh, it cost me $50 to find that out, and then you have to redo it again. So each mistake is kind of costing you money. So it is a good idea to kind of debug locally, try to make sure that at least gets through a few iterations, and then you can do the big solve, maybe make a finer mesh and then put it onto the cloud. So while it is possible to do all of the engineering in the cloud, including the pre and post and solve, we find that most folks are doing that initial refinement locally and then just submitting the larger models to the cloud when they need more resources than they have available to them locally. Now, one challenge of the public cloud can still be the amount of output that's generated, because many customers still do pre and post data management, meshing, CAD, PLM, everything's on-prem. They need to bring that data back, at least some chunk of it. And so when you have a huge amount of data and you're trying to bring that back over the internet, it could certainly be a challenge. And there's definitely multiple different technologies that can help you with that, which we'll cover in a second. So, we often say you got to consider the start to finish time. You have some time setting up the simulation, there's a chunk of time solving, and then a chunk of time downloading results. This is what you see on-prem. Now, what you'll see in the cloud is you'll have to add on that download penalty, the time it takes you to download. Someday when we do, all cloud, where we do, like I said, pre-process, mesh, solve, post-processing, all your data management, your PLM access, your CAD, everything's in the cloud, then we would avoid this whole needing to bring the data back. But customers aren't doing that today. You can certainly do remote viz, which we offer, which means doing some of that post processing on the cloud, trying to avoid bringing the data back, maybe adjusting things. But we find that users don't like juggling desktops in the cloud with their on-premise desktop, and that's a little bit of a challenge. So one nice thing about COMSOL is they have a client-server mode. So you can actually get the best of both worlds. You can have that client kind of on-prem, but you can shift the solve to a super server that exists out in the cloud. So I'm going to demonstrate here a box that has over 1 terabyte of memory, costs about $6 an hour on AWS. And this might be a kind of machine that might be difficult for you to get on for an on-prem system. But if you have a lot of physics and need a lot of memory, this would be a perfect kind of use of public cloud. So what we're going to do, this is from the COMSOL blog, is we're going to take our desktop workstation here. We're going to start up COMSOL Multiphysics locally, and then we're going to connect it to a COMSOL server. It's running on the public cloud, and then we're going to do the solution. So let's just get to that right now. We will start up our COMSOL Multiphysics. All right, now that COMSOL is open, we will open our tuning fork. Now we can connect to COMSOL Multiphysics server. This is the IP of the public cloud, and I've already created our username, so we can just go ahead and log in. Now we can go to study, click compute. Now we're going to see that this is actually running on a public cloud. This is the machine, has 1 terabyte of memory. Run top. Oh, it's already completed. Now we have the solve. It took 8 seconds. So that's kind of an example of how you can run with COMSOL Multiphysics client, but use a super server with over 1 terabyte of memory to solve those big physics problems. So one thing you don't want to do is rent, like let's say a 4-core, maybe 64 gig memory box on the cloud. The cost of that, you could just buy a laptop these days that has that kind of horsepower. So we want to reserve the public cloud for kind of renting things that you wouldn't just own. And so that kind of server kind of shows you the power of public cloud, where I was able to spin up 32 cores, one terabyte of memory in a single box for basically the same cost of lunch to run maybe a complicated simulation. Now on cloud cluster hardware selection, there's hundreds and hundreds of types of different kinds of machines that are on all the different cloud providers. However, there are really only 1 or 2 types per provider that anybody really uses that are appropriate for CAE. So we just list these on Azure, it's the H series, and Amazon, the C48 extra large. Now these are both great boxes for a wide variety of codes. You can load up specialty boxes like the one that I just showed with a terabyte of memory. And those are all available through TotalCAE. Will help you pick the instance that's best for your hardware selection. And you'll find that these 1 or 2 will cover 99% of any models that you would run. Like we mentioned, that cloud is complex, and out of the box, most of everything on public cloud is actually configured wrong for CAE. In that example I just showed you, there's over 20 steps to get the networking correct so that high memory box actually has decent memory network performance. So you're going to need highly skilled IT people to adopt public cloud. Even if they have skills in public cloud, the public cloud for high performance computing is a little more complex. There's a lot more nuances to getting all of the machines to talk correctly to each other, and it's not as Google friendly. So you'll need some definitely highly skilled IT people, or you can hire TotalCAE, and we will wrap all that complexity up, manage it for you, and present it to you with a simple interface like we've shown today in this webinar. No, and in that interface, it does support multiple cloud vendors and your on-premise system. So your users only really have to worry about one cloud. They don't even have to know, are they on Amazon or Azure, or is it an on-prem system? All of that complexity is kind of hidden behind the TotalCAE simple to use interface to make high performance computing easy to adopt. One thing about COMSOL server is you do need to have a floating network license. So while we showed a lot about how you can have elastic compute, you can rent compute time, or maybe you lease it on premise, you do have to buy the license server, and this is a fairly common model for many vendors. So you're going to need to purchase a floating network license, and then we forward that license to the cloud or on-premise cluster, either using what's called a site-to-site VPN or SSH forwarding. And these are things and technologies that TotalCAE works with your company to help get set up so that it's easy to then, going forward, just use the renting the compute cluster on demand if you're using our public cloud. And here's an example of accessing COMSOL server. You have your on-premise license server. It's accessed into the cloud on the right over a VPN, and then the engineer just accesses through our web browser or an SSH client the HPC system or a COMSOL multiphysics server like we demonstrated. And while you can have an infinite amount of hardware capacity, what we have found most customers actually are able to reasonably afford either plenty of on-premise hardware and or public cloud compute, but they're generally limited by their licensing, no matter what the vendor is. So TotalCAE's solution does calculate licensing. It will make sure that your jobs and the public cloud, for example, doesn't spin up and try to wait for licensing to show up. It'll only schedule your job to run once a license does happen. So there is queuing for licensing in most scenarios when you don't have a on-demand type of or an infinite amount of application licensing. So one strategy we see a majority of our customers adopting is a hybrid scenario where they're continuing to do on-premise where it makes sense, where they have plenty of engineering simulation. It's a just cheaper scenario, a little easier workflow. And we'll use public cloud for kind of these overflow or special needs, like I need to have that 1 terabyte memory for some special physics. These are types of great short-term rentals that really makes cost-effective use of public cloud. I just want to do a few case studies here. This customer had a solution that they needed to get fast results in their workstation, but they needed to prove that they need HPC, and because the CIO had a cloud first strategy, they were having difficulty trying to even get an on-premise system. They were having to try to figure out the public cloud, trying to figure out how to just basically get their job back faster with multiple different constituents wanting different things. So TotalCAE went in, we benchmarked their model. We were able to find a good fit both for on-prem or public cloud, and then we calculated the cost of what they were going to do. So they were going to take 10 hours on this model at 72 cores, and they wanted to run, they thought, 2 jobs per day, 5 days a week. So running the numbers, it was $1,000 a week to rent the compute time, and around $384 to basically own that core with some spare capacity. The licensing cost was the same in either way with COMSOL. And so basically it came down to $1,000 a week to rent or $300 a week to own. And so they, in this case, decided they would own due to the large amount of simulation they were doing with COMSOL and some other codes on top of that. In a different case, we had a customer who needed to win some new business, and they didn't want to really have to relearn anything new, use workflow. They wanted to use COMSOL just as they have it. They needed a lot more memory, and they could not wait a month for any type of new server with a bunch of memory to arrive, because that was going to be beyond the bid for this project they were bidding on. So they contacted us. We were able to spin up a high memory server, kind of like what I showed you, similar with a large amount of memory. They were able to point the COMSOL multiphysics client at it and get that simulation to run a lot faster so that they could meet their deadline. And again, simulation went to business, and this was a public cloud win using TotalCAE public cloud. Same kind of challenge. I had another different customer. They again wanted fast results in the workstation, pretty common request for us. And they wanted someone to completely manage it. Their IT did not have experience with Linux or high performance computing or even the engineering applications. And they didn't really have a specialist or anybody assigned to their team, but they needed to have faster time to market for new products. So they ended up getting procuring a HPC on-premise system from us that we managed, took over all their application license management, all the cluster management, became their IT group for that engineering group, and we took their runtimes from 5 days down to 4 hours, which was just a huge runtime reduction for the team. They ended up being able to do, more jobs per day, more simulation studies for better design, and they appreciated that the complete cluster management done by TotalCAE just made HPC access seamless, kind of worry-free. It was a tool that they could rely on every day, knowing it was there to get their simulation done. They didn't really have to think about, all of the complexity going behind the scenes from the time they pushed the button to the time they got the results back. We also, beyond high performance computing, have a lot of other kinds of engineering specific IT solutions. One of these is backing up work in progress. We have a lot of customers that they have access to possibly 100 some terabytes. Data is very cheap these days that they use for their intermediate engineering results, and often that's more storage than their enterprise is able to back up. And so engineers end up doing self backups because they really don't want to lose a lot of that intermediate data. They're not sure if they're going to still need it, but it's not so worthwhile that they think that's going to be backed up onto tape and offsited by corporate IT, which may be charging a dollar per gig or some depending on the price, just not cost effective. So the problem with doing these kind of poor man's backups is that that ends up putting engineering data on removable media. It can get lost. It can't be organized. So TotalCAE makes a product called TotalCAE Storage Camel. Basically, automatically encrypts all that work in progress, and then on the client will then upload those encrypted files to the cloud automatically. It's totally lights out. You have up to a petabyte of storage. It's just pennies per gig, and it's very easy for the engineers. Just if they accidentally delete a file or corrupt it, they can easily self-restore. Super high reliability, much more reliable than individual drives. It also avoids people losing their thumb drives or external storage drives with a bunch of engineering data on it. So if you're interested in learning more about many of the products, solutions, and services that TotalCAE can offer, please visit our website at www.totalcae.com/learn or contact us at sales@totalcae.com.